in this video I'm going to take you through a couple of examples of how to calculate reacting masses, but also more specifically how to calculate what we call reagents in excess. So a reagent in excess is just the ingredient, the reagent, the thing that goes into a chemical reaction, the reactant, that is left over at the end of the chemical reaction. Because as we know from reacting masses, certain masses or volumes or concentrations, certain numbers of moles will react to create other certain numbers of moles, which you can then convert into masses. And if you don't have exactly the right amount, you will have some left over. So the material that is left over at the end of the chemical reaction, that is called the reagent that is in excess. Okay? The reagent or reactant that gets completely used up, that is called the reagent that is limiting, the limiting reactant. Okay, reactant and reagent can be used interchangeably. Okay, so let's have a little look at this one here. It's obviously part of a larger question, but it's still relevant, and you don't need the previous information to do it. So let's have a little look. Where'd my calculator go? There it is. 4.8 grams of calcium is added to 3.6 grams of water. The following reaction occurs. So you're given the balanced chemical equation. You don't need to do that. In sum, you will have to. The number of moles of calcium and the number of moles of water is what you've got to work out there. So in order to do that, I'm going to use my mass mole triangle. Don't forget that. So I want the number of moles. So the number of moles is the mass divided by the relative molecular mass, or atomic mass in this case because it's calcium. So the number of moles of calcium is the mass of calcium, 4.8 grams, divided by the relative molecular mass of calcium. You'll need a periodic table for this. It is 40. So 4.8 divided by 40 gives us 0.12. So our answer is 0.12. The number of moles of water, you do the exact same thing. So the moles of H2O is again going to be the mass, which we're given here is 3.6, divided by the relative molecular mass, which for water is 16 plus 2, which is 18. Again, use your periodic table for that. So 3.6 divided by 18 gives us 0.2. So I can write 0.2 here. So I've got 0.2 moles of water, and I've got 0.12 moles of calcium. All right. Which reagent is in excess? Explain your choice. Okay, so what I need to do is I need to look at how much should be reacting. So if I look at the ratio, it's 1, why is that so small? It's 1 calcium to 2 waters in my equation here, because remember there's an invisible 1 right there. Okay. So 1 calcium to 2 water. So I need to work out how much water should react with my calcium. So 0.12 moles should react with, multiply that by 2, 0.24 moles of water. What that's telling me is I need 0.24 moles of water to completely react with all of my calcium. Do I have 0.24 moles of water? No, I only have 0.2. So that means my answer there for which reagent is in excess, that is going to be calcium. And the reason is because you need 0.24 moles of water to fully react, and you only have 0.2 moles. So that's how you would work out which one is in excess. Calculate the mass of the reagent named in number 2, which remained at the end of the experiment. So we've already established that we need 0.24 moles of water, but we don't have that, we only have 0.2. So I know that my calcium is in excess. So what I'm going to do is I'm going to go, okay, I've got 0.2 moles of water, and I'm going to say, okay, how many moles of calcium will that fully react with? Well, in this case, I divide it by 2, so that means it's going to be 0.1. How much did I start with? Well, we worked out before, I've got 0.12. So my excess calcium, what I've got left over, the stuff that doesn't react, that is going to be 0.12 minus 0.1. Because if you're not sure why, 0.12 is how much I've got, 0.1 is how much reacted. So what I've got left over is 0.02. Then it's asking for mass. Mass, if we go back to our triangle, mass is of course the number of moles multiplied by the relative molecular or atomic mass, molar mass. So number of moles, 0.02 multiplied by 40, 0.02 multiplied by 40 gives me 0.8 grams. So 0.8 grams is my answer there. Okay, if you didn't understand any of that, drop it in a comment down below. Let's take a look at another one. Okay, in this one, you can do something slightly different. Well, same strategy, same way of solving it, but they're going to ask you for something different. So again, this is from a different question. We've got 0.07 moles of silicon reacting with 25 grams of bromine. They've given you those in two different units there, moles versus grams. Which one is the limiting reagent? Okay, last time they asked you for the one that was in excess, that means left over. This time they're asking you for the limiting reagent. That means the one that you don't have enough of, the one that gets completely used up. So let's go step by step through how we would do this. Okay, so we've got our balanced equation. I've got 0.07 moles of silicon. How much bromine would I need to completely react with that? Well, it's 1 to 2 silicon to bromine. So I just double it. So that's going to be 0.14. That's how much I need. Let's find out if I've got that much. I've got 25 grams of bromine. All right. So the number of moles, again, just go back and look at the triangle if you're not sure of this equation, is the mass divided by the molar mass. So the mass here is 25. The molar mass of bromine, one bromine atom is 80, but I've got two bromine atoms. It's a diatomic molecule. So it's 160. So 25 divided by 160, 0.156. So that means I've got 0.156 moles of bromine. So do I have enough to fully react with the silicon? Yes, I do, because I need 0.14, and 0.14 is smaller than 0.156, which is how much I've got. So I have more than enough to react. So what is the limiting reactant? That's the one that's going to be completely used up. Silicon is the limiting reactant because 0.14 moles of bromine are needed to fully react. 0.15 moles are used. And then you can expand that. You can say, therefore, all the silicon will react. All the silicon will react. Going from that, we can just finish with a little reacting masses question here. How many moles of silicon bromide are formed? That's silicon bromide, SiBr4. So which one is the limiting reactant? Well, I could use 0.07 or I could use 0.14 or 0.156. Which number do I use to do my reacting masses? Whenever you do reacting masses to find out what you're actually going to get, you use the limiting reactant. And that's because there's not going to be any left over. It's all going to be used up. If you try to use the reactant that's in excess, then you're not going to react at all. You're going to have some left over, so not all of it will get turned into the new thing. So how many moles of SiB are formed? This time you just do a simple reacting masses calculation using the 0.07, not the 0.156. So it's 1 to 1, so the answer, you don't even need to calculate it, 0.07 moles. And that's your answer there. So a quick recap of the method that you use for this. You will always be told how much you've got of each of your reactants. Convert them both to moles if they're not already in moles. Once they're in moles, see how much you would need for each one to fully react, and one of them will be bigger than the other. Hopefully my examples that I went over just a minute ago will make that clear. Okay, if you have any questions that you're not sure of or that you would like me to go over in a video, please post them below. Thanks for watching.